Welcome. In my previous video, we learned about molar volume, which can be used to determine the number of moles of a gas present within a given volume. However, what about solutions? Molar concentration is simply the number of moles of a chemical present within a given volume. In chemistry, for volume, we like to use decimeters cubed, or how I prefer to write it, mol d the negative third. Both of these are the same thing. So let's say that we had 1 mole of table salt, NaCl, and this is going to be dissolved in 1 decimeter cube of water. Then the molar concentration would simply be 1 mole of sodium chloride per dm cube. But what if we had 1 mole of sodium chloride over a smaller amount of water? Let's say 0.7 dm cube of water. Then simply we just divide 1 by 0.7, and this would give us a molar concentration of 1.428 moles per decimeter cube of solution. What if we were to have a given mass? Let's say that we had 20 grams of sodium chloride dissolved in 5 decimeter cube of water. Then how we would find the molar concentration is that we'd first take this mass of sodium chloride and find the number of moles present in it. How we do this is that first thing that we do is that we find the RFM, the relative formula mass of sodium chloride. So we know that sodium has a relative atomic mass of 23 and chlorine has a relative atomic mass of 35.5. To find the relative formula mass of sodium chloride, we'd simply add these to get 58.5. And as we learned in the first video, the numerical value of the relative formula mass, or RMM or RAM, of a given element or chemical is going to be the same numerical value of the number of grams which contains 1 mole. So now we know that 58.5 grams of sodium chloride contains 1 mole of sodium chloride molecules. So now that we know that 58.5 grams contains 1 mole, how will we be able to find the number of moles which is contained within 20 grams? We can now put this into our equation by saying 20 grams of sodium chloride contains X moles. And now to put this into a linear equation, we can cross multiply these to then say 20 grams times 1 mole is equal to 58.5 times X moles. So to get X by itself, we divide this by 58.5 and the units cancel out. So now we have 20 divided by 58.5. So we know that 20 times 1 is just 20. So now we can put into our calculators 0.341880341. So in chemistry, we use standard form or scientific notation in order to write our values. So we would say that 3.41 times 10 to negative 1 moles is present in 20 grams of sodium chloride. So this is the amount of moles present within the 20 grams. So we can substitute the 20 grams for this. So remember that we now have to divide the number of moles by the volume of solution. So this is going to be divided by 5 decimeters cubed. So if we put this into our calculators, we will get 0.0682 mole per dm cube. So once again, we put this in scientific notation to say that the molar concentration of 20 grams of sodium chloride in 5 dm cube of solution will be equal to 6.82 times 10 to negative 2 moles per dm cube. So with that being said, this will be the end of the moles series on this channel. If you haven't watched all the videos, please look for the playlist. If there is another topic in chemistry, math, any subject you can think about, apart from maybe accounts, if there is any topic which you'd like for me to cover, please do just leave it in the comments down below. I'll make my best effort to make a video or a series on it. So once again, thank you for watching and bye bye.